All right, so here I've got my cyber range set up, and it works like this. I've got a Windows Server 2016 machine installed locally, running in VMware. And if I open up a new command prompt window, I can do ipconfig. And I've got a local IP address, which is going through several layers of IP address translation. Well, at least one in my machine and then off to my router to another. But I'm on the internet. I can ping google.com. Okay. And what I've done is I've found a vulnerable product to run. There's this thing called Apache MQ, and I don't even know what good it is, but it's something that runs on Windows and has a known vulnerability. So I downloaded that. It just downloads as a zip file, then you unzip it, then you just run it with a simple command line command. And it's listening here on port 8161. Now, since I'm behind network address translation, if I'm listening on a local address, nobody on the internet is going to be able to see it unless I were to configure port forwarding and everything. But to avoid all that, I just use WireGuard. I've got my Debian cloud server here, and I've installed WireGuard on the Debian machine and on my Windows machine. WireGuard is the new hotness in VPNs. Everybody's loving it. It's got built into the Linux kernel in modern versions of Linux. It's really nice. So what you have here is both your server and the client have a public key and a private key, and you have a nice GUI to configure it. So you can totally connect them with WireGuard. And that means if I look at my ipconfig output, which was here, I'll do it again, ipconfig, I've got that local address 172.16, which goes off to the internet through layers of address translation, but I also have another address which goes directly to my server, 192.168.104. And my Linux server here has got a virtual interface called WG0, which goes to 192.168.101. So I can ping 192.168.104 in my Windows machine. And so these two machines are now connected as if they were on the same local network, which is very nice. I do not need to open ports in a firewall or on the Linux side anyway. And I don't need to configure port forwarding or anything like that. This is a good arrangement. So now this machine is on the same network as that one, and that means I can run, say, an Nmap scan to look at my Windows machine at 192.168.104, and on port 8161, which is the only port I care about, the port for that active MQ stuff, and Nmap will find it. So there we are. Nmap finds it. Okay, so let me go find the project, which is this one here, Metasploit versus ActiveMQ. And of course, here we're just going to practice using Metasploit. That's this section. We're going to do a variety of tricks with Metasploit. So once you've got a connection and you're seeing the that it's open, now we can exploit it. And I used to use Kali, which is pen testing distribution with all these tools installed. But when I moved everything to the cloud, it wasn't immediately obvious how to get a Kali machine working in the cloud. And I realized I don't need one. I never use very many tools. I can just use naked Debian and install the one or two tools I need for my purposes. And that's a good idea. It's a good idea to get versatile, because this solves another huge problem. When I'm doing CTFs and other attacks, I really need a machine with a real public address and nothing in the way. And using a cloud machine is a very good answer. So you just install Metasploit on Debian, which is pretty easy to do. And so once you've done it, it's sudo msf console. I can use the -Q not to have a big banner. And now that I've found that I am running ActiveMQ on the target, I can see what ActiveMQ exploits exist. You can just search by the name of it, and it will show me there are several known ActiveMQ exploits. All right. So the one I decided to use was this traversal upload, which is this one here. So I can use that one. And whenever you're using a Metasploit exploit, you always want to use show options or show info. Show info will give you a complete description of where it came from and also how good it is. Rank excellent is the best. The lower the rank is, the more likely it will fail or even crash the server or do something else bad. The excellent ones are nice. And the other thing you can do is figure out what essential data you're going to have to give it. Let me just run this again. All right. So here I've got a password and a path and a port and so on, various things here. But a lot of these have default values. All right. So in this case, the only thing I'm going to need to set is R hosts and L hosts. R host is the target to attack, and L host is my local server to listen on. So I'm going to set R hosts to 192.168.100, and it's 4 this time. And my L host is the Linux server, and that's 192.168.101. And I can just use the default settings and run this exploit. I never typed correctly. All right, there we go. And it reached the server. It started the reverse handler. And I should get a shell. It is a Java-based server. Yep, so that's always very slow. All right, so now I've got a command shell opened. And if I just press enter, I now have a Windows DOS-style command shell. I didn't get an interpreter shell, I got a DOS-style shell, but still I can do things like dir and see the directory and things like who am I think these days in Windows. Yeah, so I'm the administrator, which is pretty ridiculous, but I did run this thing on a server logged in as administrator. So you've got command shell there available. So that's the simplest Metasploit. The next thing is something I've always wanted to do, and it turned out to be pretty easy, adding a custom exploit to Metasploit. Oh, this is something I've done many times, but I'm always very clumsy at it. So I was very happy to have an opportunity to really write it up correctly. One thing that is very common is you do an Nmap scan on a target, you find some version of something running that's vulnerable, but you don't have a Metasploit module that will attack that version of that product. And yet, if you search in exploit DB, there is an attack on it. But what you have there is not a Metasploit module. It's some other kind of code you have to use. Anyway, so in this case, I had this thing called vuln server. Vuln server is it's not a real commercial product. It's a deliberately vulnerable server written in Visual Studio for people to learn exploit development. And every exploit development class, including mine, will use this thing to practice on, but it's not a Metasploit because Metasploit doesn't contain a module for just a test product like that, but you can make one. So you can add a custom exploit here. So if you do find an exploit, which is already written to be a Metasploit module, somebody wrote one and put it up. If you want to add it, the only thing you have to do is you have to put it in the right folder. And there are a lot of different versions of Metasploit and a lot of tutorials that will lead you to the wrong place. But for Debian 10 in the cloud, this is where you put it, root.msf4 modules exploits. Then you can put in the exploit. It's a Ruby file. You put it in there, and here's the Ruby file. This Ruby file is really not very complicated. That's all there is to Metasploit exploits. And then you run Metasploit, and you search for vuln server, it won't be there. Then you do reload all, which will search through all the folders where exploits might be, and then it will be found. So that is the process of adding a new exploit that somebody else wrote to Metasploit. So that's a skill to get good at because it's very common that you want to do that. And another skill that's good to get is writing your own Metasploit modules. If you do an exploit development process, like I do in the class I teach and many others, where you'll find something like a buffer overflow, and then you'll figure out how to control the instruction pointer and how to inject a shell or something, you'll eventually end up with some proof of concept code written in something like Python. And a lot of people do that. They publish their proof of concept code. So here's something called VU Player, which is a product with a buffer overflow. And this was only like a month or two ago. 5/22 is when this module was put out of this year. So somebody wrote a proof of concept, but they just wrote it in Python. And they did not make a Metasploit module. And I wondered how hard would it be to make the Metasploit module, and it turns out to be not that hard. They even give you a template for Metasploit modules. It's written in Ruby, but Ruby and Python and JavaScript all look about the same if you're sloppy enough like me. It's just a question of whether you have to have a semicolon and stuff. And they give you the format, so all you have to do is fill in stuff. There's some text you fill in to describe the module, then targets, and then you just fill in the components. So you fill in the text, then you have to add a ROP chain to this one. The original model had a series of addresses because it will attack machines even if they're using address space layout randomization. And the template here did not have ROP chain as an option. So I just went and found another Metasploit module that has a ROP chain in it. I just Googled for one and found this ZenWorks one. So here's somebody's Metasploit module. And the important point is it's got a ROP chain right here. So this is my example of how to do it. You define this thing called create ROP chain, and you paste in the ROP chain that you get from the from Mona in Immunity is where this came from, of course. And you can build it. So you'll find it's actually not that difficult. You just add 2 or 3 pieces, you just plug them in like modules, and then you make your own Meterpreter exploit here. So you can make your own Metasploit module. It's good thing to practice doing. And then another thing, which is the way I probably most commonly use Metasploit in my classes, is rather than attacking a vulnerable old version of a server process, which you just use social engineering. You make a Trojan and then trick people into running your Trojan. So this will work, but your server has to not have any antivirus because all the antivirus is onto this malware. So you can make malware with Metasploit by just using MSF Venom. You can tell what exploit you want to run, fill in the parameters, and create an exe called fun.exe. And if you can trick your person into running that exe, then you get a shell. So it's a useful technique, although the hard part is to get past antivirus. And anyway, these are basic techniques you should know, although in the real world, you're going to have to learn to evade antivirus, or you're going to have to quit using canned products like Metasploit and learn living off the land, which I'll talk a little bit more about later. So let me stop this one.